This is going to be the entire section on solving a quadratic equation. And we're going to go through the entire thing. It's going to be a little bit lengthy, but this is great if you just need a little bit more review on the entire lesson itself. So for this lesson, we're going to start off with some stuff that you already know, a little bit of review. So let's bring some in. I want you to solve each one of these. And at this point, you should be able to do this, so go ahead and push pause now whenever you get your answers and come back and push play again. Check your answers. The key here is that it should be a plus or minus in front of both of these, because m in this case can either be a positive 4 or a negative 4. If we look at that second step where it says m squared equals 16, m can equal 4, 4 squared is 16, or negative 4. Negative 4 squared is negative 4 times negative 4, which is still a positive 16. So that's the only real catch on these, is that we need to remember that there are always two answers to these. Because when you square something, it can either be a positive or a negative. It doesn't really matter. All right, let's try another one here. So go ahead and push pause now whenever you obtain your answer. Then you can come back and push play again. Check your answers on these. Again, the same thing. It should have had a plus or minus on both of these two. The catch here is that you make sure to isolate that x squared before you take the square root of both sides. So on, for instance, number 2, we subtracted 5 from both sides first, then divided by 4, so we could isolate that x squared before we took the square root of both sides. We're not going to automatically take the square root of both sides at the first step. It wouldn't make sense to do that. All right, now we're going to bring in some real-life equations of these exact style ones that we've been doing. It says an object is dropped. The speed which it falls continues to increase, ignoring any sort of air resistance. Its height h, so this is what h equals, and this is the height, can be approximated by the following falling object model. All right, h is the height in feet above the ground. T is the time in seconds that the object has been falling. Okay, so if I haven't released it yet, I'm about to release it, then my time would be 0. S is the starting height from which the object was dropped. Okay, so h is the height in feet above the ground, t is the time in seconds, and s is the starting height, wherever we started. All right, let's bring in the example problem here. This one says that Mr. Moore is going to drop a water balloon from a height of 144 feet to the nearest tenth of a second. How long will it take the balloon to hit the ground? Assume no air resistance. So I'm going to bring back in the equation here, just so we have something to kind of base that on. This is the equation. This is the negative 16t squared plus s equals h. Okay, so now I'm going to bring back in the original problem here. The height was 144. Now 144, that was our s value. That was our starting height. How long will it take to hit the ground? H represents the height in feet above the ground. So the question asks us to find the time it takes for the container to hit the ground. Well, we know what the ground is. We know what h is, and we know what s is. Our initial height, s, is 144 feet. Our ending height is the ground, so that would be the feet above the ground. The ground is 0 feet above itself, so your height when it hits the ground is 0. And the time it's going to take to hit the ground is the big unknown. That's the one that we don't know. So now we can start to kind of plug this in. We know that s is 144. I'm going to plug that in right here for s. H is 0. I'm going to plug that in for h. So let's bring that in here. This is what my new equation looks like. 144 is the feet above the ground. 0 is the ground. That's the height above the ground after it hit. All right, so now we're just going to solve it like normal. Go ahead and try that one now. Solve it by hand using the same rules that we just did. Go ahead and push pause right now when ready to come back in. You can push play again. Okay, you should have obtained an answer of 3 seconds. Now on this one, the mathematical answer is plus or minus 3. However, the real life example is 3 seconds. We don't have negative time. We can't go back in time yet. We don't have a time machine or anything along those lines. So it's just going to be a positive 3 seconds. But normally, if it were doing a normal math problem and I just gave it to you, 0 equals negative 16t squared plus 144, your answer would be plus or minus 3. But in this case, it's only a positive 3 because in real life, time only goes forward. It doesn't go backward, unfortunately. All right, so now let's bring in one. The next one we're going to look at here is a quadratic equation. We're trying to find what the value of x is. So when we're solving a quadratic equation, we have three major steps that we need to do. The first step is to write the equation in standard form. And what standard form means is basically getting everything onto one side. Standard form would make it a lot easier if you can have this the leading coefficient, that first number before the x squared. That needs to be a positive number. That will make your life a lot easier. But basically, we're going to get this 6 and move it over to the other side. So in order to do that, we're going to subtract 6 from both sides. If we subtract 6 from both sides, we get our new equation of x squared plus 5x minus 6 equals 0. Okay, so that's step 1. Get it in standard form. Step 2 is that we have to identify what a, b, and c are. Now, we did that in a previous lesson. A is the leading coefficient. That's the number before the x squared. B is 5 in this case. That's the linear term, the one before the x. And c is always the number. There's no letter associated with it. C in this case is -6. Well, now that we know all three of those, the third step is going to be to plug it into the quadratic formula. Remember, the quadratic formula is this right here. And all we're basically going to do is we know what a is, we know what b is, and we know what c is. We're just going to plug that into the quadratic formula. So I'm going to do that now. The tricky part, usually what I see, is the b value. We need to make sure that the original b value is +5, so it's going to be -5. That's our first step, negative b plus or minus. So it's negative b, so it would be -5 plus or minus. Then it would be 5 squared minus 4 times 1 times -6 all over 2 times 1. We're just filling that in. We need to simplify that a little bit. We know what 5 squared is. 5 squared is 25. -4 times -6 gives us a +24. That's all divided by 2. Well, 25 plus 24 would be 49. So now we have -5 plus or minus the square root of 49 all over 2. And we know what the square root of 49, fortunately for us, that is a perfect square. That is 7. Now we're going to end up with two answers here. And the way that we get two answers is our plus or minus. So we've got -5 plus 7 over 2 and -5 minus 7 over 2. That's our plus or minus there. So I'm going to simplify that a little bit further. -5 plus 7 is 2 divided by 2. And then -5 minus 7 is -12 divided by 2. So I'm going to end up with two answers here. My x values are 1 and -6. Now let's go on to the next slide. I'm going to have you try one here. We'll bring in our next one. There we go. All right, now I want you to solve these two. Go ahead and push pause right now. Whenever you complete the problem, then come back in and push play again, and you can check your answers. There you go. Double checking those just to make sure. You should have come up with whole numbers here. Each one of these has two different answers. But you want to just double check and make sure that you did all your calculations correctly. All right, now let's look at another one here. Go ahead and solve this one now. So using the same process. I'll give you a hint on this one. You're not going to end up with an exact whole number. But go ahead and try this one. Push pause now when we're ready. Come back and push play. Check your answer on this one. You ended up with 3 plus or minus the square root of 73 all over 4. Sometimes you'll see that written as 3 plus the square root of 73 over 4. Then the second answer would be 3 minus the square root of 73 over 4. This is the shorthand way of writing it. So that's okay if you want to write it. Either way is okay with me. All right, let's bring in the next problem here. And this one just gets slightly more complicated, but not very much. Go ahead and try this one. Push pause right now. And when you've got your answer, then come back and push play again. Check your answer on this one. So we've got enough practice with those. These are, when we're asking for an exact answer, this would be the square root of 41, 1 plus or minus the square root of 41 all over -4. There are ways in which you can find this one on your calculator. I will add those to the video. I'll put them at the very end though, because if I'm looking for an exact answer, which I do many times, you have to use a quadratic formula. The square root of 41 does not have a decimal which you can round it to that is equivalent to it. They've got some that are really close that we round it to. They're approximates. But the square root of 41 is an irrational number, so that one continues on forever. So the only way that we can get an exact answer here is if we use that quadratic formula. All right, now let's bring in some real life equations here. So we can kind of use the same thing that we've been doing, but we're going to do some real life. But first, let's do this. It's going to make our life a little bit easier. Why don't I transition it we will show you how to solve quadratic equations on the calculator. I'm going to do the TI Inspire right now. I'll put the TI-84 at the end of the video, so if you have a TI-84, just go to the end of the video and you can watch it. But you're going to need to know how to do that in order to solve the next real-life problem. So I'm going to add that in right now. Right now we're going to be working to try to solve this quadratic equation. We're going to be using our TI Inspire calculator. Now we can normally, what we'd want to do is move this 5 over and then we could solve it by hand. But we want to get a little more practice on the calculator because we're going to be getting into some more difficult problems that are just going to be too hard to do by hand. So what we want to do here is we'll take this equation here. We're going to enter it into our TI Inspire, but we're going to enter it in as two separate equations. So, and I say y1 here on the TI Inspire to probably be an f of x1, f1 of x, and then for your x squared plus 4x, and then we're going to enter in a second one of y equals 5. So let's bring our TI Inspire in. Okay, so here we go. Now, I've already got an equation in there, so what I want to do here is I want to just go ahead and clear that one out. So the way I do that is I go to tab, and then I can go up. That gives me my first equation, and I'm just going to delete that one out of there. Okay, now my first equation there was x squared plus 4x. So I'm going to take that one and I'm going to enter that into my TI Inspire. Okay, so I go, x is down here at the bottom, x squared plus 4x. Then when I'm done and I'm ready for that, I'm going to hit enter. And here's my graph. It's in blue, x squared plus 4x. My second equation was just simply 5. And that was, see how I break these into two separate equations? Whatever's on one side I put in one, whatever's on the other side I put into the other equation. Okay, so we're going back to our Inspire here. And I need to create a second graph, and the way that I do that is I just hit tab, and notice how this is f2 of x, so this is my second graph. I'm just going to enter in 5, and then I hit enter. So now I have two graphs here. I've got one that's the parabola, this is the x squared plus 4x, and the other one is just 5. It's a horizontal line, y equals 5. Now what I need to do on a quadratic, when I'm trying to solve a quadratic, I'm going to have two answers. And notice how I have two intersection points. So that works out pretty nice. Okay, so I need to find both of them in order to get my answers. So what I'm going to do here is I'm going to go to the menu button. I click on my menu, then I go here to Analyze Graph. Now we've done this before. We found the minimum, the maximum. We found other things as well. But what we're looking for here is the intersection. I'm trying to see where these two lines intersect. So I click on option 4. So I need to have this one intersection here and one over here. And this is similar to the way that we've done our minimum and maximum, a lower bound and an upper bound. What I really just need to make sure is that I include this intersection in my data, if you will. So I click on the left-hand side of it, and then I automatically drive it to the right-hand side. And see how whenever I drag it over, it automatically pops up and says, hello, this is your intersection point. That's perfect. So as soon as I cover that, then I know I've covered enough. So I do that when I'm on the what they call the upper bound, which is kind of the right-hand side of the intersection. I click again, and it tells me that my intersection is negative 5, 5. Okay, which is great. We know that our x value is negative 5, our y value is positive 5, and we do that right here. Now I'm going to do the same process again, but I'm going to do it for this one over here. So again, I'm going to go into Menu, Analyze Graph, and Intersection. So you go Menu, 6 is my option, then option number 4. Okay, and again, I just want to make sure that I'm going to cover the entire intersection point. The lower bound will be the one on the left-hand side. Then you drag it, and as soon as you drag it over, then you see that intersection pop up, and it tells you exactly what that intersection is. As long as I have that in there, then I'm good. I can click it again, and it tells me. So my two intersections here are negative 5, 5, and 1, 5. Okay, so now I've done the hard work. If you'll notice here, the x values on both of these are 5. Well, we knew that because that was our second equation that we entered in. Our second equation was y equals 5. Now, when we're trying to solve these, when we're trying to solve this equation here, we're trying to solve it for x. What does x equal? We have two answers, and my two answers here for x are going to be negative 5 and 1. Okay, so we enter these in, we find our second point, positive 5, 1. But really our answer here is x equals negative 5 and 1. Excuse me. So negative 5 and 1 are our two answers, and we got that directly from these points, negative 5 and positive 1 right there. Okay, so now that we know how to do it on our calculator, I'm going to have you try to solve this one. Now, this one says P represents the price of gold. All right, and it gives us the equation. This is from the years 2000 to 2008. P represents the price of gold. T is the number of years since 2000. And we want to find out when the price of gold reached $310 an ounce. So we're going to plug in 310 for P, then use the quadratic formula. Then we're going to solve it via our calculator. You're going to look for those two intersecting points, okay? You're going to have one positive and one negative. Now, we'll talk about that a little bit more in just a second. So we've got our two equations. You're going to type the first one into your calculator just like that. That's going to be your y1. Your y2 is going to be 310. Go ahead and type those into your calculator right now. Go ahead and push pause. Type those into your calculator and see if you can find the intersection point. There are two of them, but see if you can find both of them and see why we're only going to use one of them. Okay, hopefully you found it. And I didn't tell you what to round this one to, but as long as you got somewhat close here, I'm happy. The one that you're not going to use is the negative one. The reason why we don't use negative is because that t value in this case, the 3.08, we don't have a negative. We can't go back in time. It's kind of that same theory. We can't go back before the year 2000. This model only works for the years 2000 to 2008. So we go to the, we only go to the positive one. So this is 3.08, comma 310. Now we've got to figure out what those mean to us. Well, 3.08 is t, and t represents the number of years since 2000. So what we're going to do is we're going to take that 3.08 and add that to 2000. That's the number of years since 2000. So that would give us 2003.08. So basically during the year 2003, gold reached a price of $310 a share using that model. And that model is fairly accurate to what actually occurred. All right, now I'm going to have you try one on your own. Here is this one. It's real similar to the one that we just did. I want you to go ahead and try to figure this one out using your calculator. So push pause now, and then when you're done, you can come back and push play. Okay, hopefully you found out that it was during the year 2004. Now this particular one, if you wrote 2005 because you rounded up to the next year, that's probably okay for the moment. But that's basically the big parts of what we want to do, is to be able to interpret those, okay? 400 in this case represented P, and P was the price of gold. So that was 4.57 years after the year 2000, gold reached a price of $400 a share. Okay, so now we want to bring in another real life one, just to get a little bit more practice on this one. This one here is similar to the one that we did earlier. All right, Mr. Moore throws a water balloon down at a rate of 20 feet per second. So instead of just dropping the water balloon, I actually take it and I throw it down as fast as I can. Maybe 20 feet per second isn't really that fast, but it's okay for right now. So from a height of 40 feet, we want to round our answer to the nearest second. How long did it take for the ball or the balloon to hit the ground? All right, so we bring back in our equation here. Now it asks, here's our equation. Now that's the equation that I gave you over here. If we go back one slide, there we go. And now on this one, the actual question asks us to find the time it takes for the water balloon to hit the ground. Well, the initial height on this one is 40 feet, so that's our S value. We'll plug that in for S. The ending height, which is the ground, is 0. That's our H. The only thing that we added here is we added this V of t, okay? The time it takes to hit the ground, that's our unknown. That's what we're trying to find. V, though, we know what V is. V is the initial velocity, so that's negative 20. So we're going to use that. We're going to plug that in for V. So we're going to end up with a 0 equals negative 16t squared minus 20t plus 40. Okay, and you'll see that here. There's where it is, where it's all plugged in. Now I want you to go ahead and solve this one. And let's use the quadratic formula on this one. If you want to, you can plug it in your calculator to get a little bit more practice there. Your intersection point would be 0, though, on this one. That's the y-axis, and that's okay, too, if you want to use that. So go ahead and push pause now. When you get your answer, come on back and push play. Check to make sure you only got one answer on this one. There are actually two answers here, 1.075 and then negative 2.325. However, the negative doesn't work because we're still dealing with time. And unfortunately, we can't go back in time, so the only answer that's applicable here would be 1.08. And again, that's because we have a real life scenario. If it's just a normal math problem, you'll list two answers. Real life, you have to kind of really interpret what it's asking, what the meaning is. All right, let's get some more practice on these quadratics. So here is an equation I'd like you to go ahead and solve. And let's use, I want an exact number on this one. So let's use the quadratic equation. That'll give us an exact number. Hopefully you found out the answer was -3 plus or minus the square root of 3 all over 2. This one we needed to reduce down. If you look the second to last line at the right-hand side, it says -6 plus or minus 6 square root of 3 all over 4. Well, in that -6, 6, and 4, we can reduce all of those. We got to figure out a number that goes into all three of those. And for those of you who are really quick, you'd find out it was 2. You take a little practice, you can eventually get a 2. So we take a 2 out of each one of those. So if you want to just divide each one of those by 2, that works as well. That gives you the same answer. All right, let's get some more practice on that. Again, I want you to use the quadratic formula on this one. Go ahead and try this one and push pause now. Whenever you're ready, come back and push play. Check your answer here. Again, you should have had two answers, -2 plus or minus the square root of 5 all over 2, and hopefully got some more practice with reducing there. -8, the 4, and the 8, we have a 4 that can go into all of those. So if we divide each one of those by 4, that'll work as well. Over here I modeled that I factored a 4 out of the top. If that makes it confusing to you, that's fine. You don't have to use that method. It is one method, but you don't have to use that one. And this will conclude the video. I will include the TI-84 at the end of this video, but otherwise you can go back through and review it if you'd like, if it makes it a little bit easier for you.
Right now I'm going to show you how to solve this quadratic equation using your graphing calculator, okay, your TI-84. And it will work on the TI-83 just the same. On this one, normally what we would want to do is first move this 5 over to the other side, so we subtract 5 from both sides. However, there is another method that we can use, and we can use our calculator. And the first step when we're using our calculator is we want to enter this in as two separate equations. So y1 will be what's found on this left-hand side. And it really doesn't matter which one's y1 and which one's y2. But so y1 right here, I'm doing this x squared plus 4x. Okay, I just leave that there. And then for y2, I'm going to have it be just plain old 5. Okay, so let's bring in a graphing calculator here. All right, so here's my graphing calculator. And you can go, let's pretend as if we're on the home page here. You want to go right here to where it says y equals. Type that in. So here's your y equals, and you can do these y1 I've got over here as x squared plus 4. So I'm going to type that in. Your x again is found right here. Notice as I click on these that they turn red. So we've got x squared plus 4x. That's my y1. Now my y2 I'm going to enter in as just 5. Now that's going to be a horizontal line. So that's 5. Okay, I'm going to, if you'll go up here to your window, go zoom, and we're just looking for the standard window at this point. We'll see what that looks like. We may need to change it, but for the moment we're just going to go standard, which is option number 6. So I'm going to go down here to 6. That'll give me a -10 to +10 in both my x's and my y's. And let's see what this looks like. That's my first equation. That one's in blue. My calculator does it in colors, but yours may be just black and white, and that's fine. Okay, so right here is my horizontal line at y equals 5. It goes straight across. That's the one in red. And then my quadratic, this is my x squared plus 4x. That's the one in blue. Now, in order to solve this one, if you remember right, in quadratics we have two different answers. Okay, so what we're going to do is look for the intersection of these lines. We're going to look for the point right here where these two lines intersect. That will give us one answer, and the point right here where these two lines intersect will give us our second answer. Okay, so we've used these functions before, our second trace function, but that's what we're going to use again. We go to second trace. This time I'm not looking for a value or minimum or maximum. I'm looking for the intersect, option number 5. So I'll scroll down for number 5 and I'll hit enter. And you'll see my cursor is right here blinking. It does not matter which side that you start with. So I'll go over here. I'm just going to start on the left hand side. Notice it just kind of follows along that graph, and it's on the blue line. If you want to switch it to the red line, you can use this up arrow. Will automatically switch it to the red line that's closest. Okay, but I started on the blue. I'm going to stay on the blue. All I want to do is get somewhere close over here to where this intersection is, okay? That's pretty close, so I'm okay with that. And notice how this says first curve. So that's our first graph. We're on the blue one. That's our first one, so we're good there. So I hit enter. Now it automatically jumps to my red line, okay, my y equals 5. And it jumps to the spot where it's nearest to the first one that I entered, which is great because I want this intersection right here. So the second curve, this is my second graph, that's my red line, so that's good. So I hit enter there. So now I've entered in my first one, my blue line, my second one, which is my red line. Now it asks me to guess, so I hit enter again, and it tells me my intersection, x equals -5, y equals 5. Okay, so going back over here to our original equation here, well, we know that y equals 5 because that's what one of our lines. So now we know that y equals 5 and x equals -5, and we can bring back in the calculator to tell us that. X equals -5, y equals 5, so we're on the right path. So this is 1 point. If we wrote it as an ordered pair, it would be -5, 5. So we're okay there. So now we found one of them. But with a quadratic equation, we've got to find the other. So now I'm going to do the same thing. I'm going to go second trace, and I'm looking for the intersect, which is option number 5 again. Now, notice how it started right here where I ended, because that was my first one, which was great for the first one, but that doesn't help me for the second one. So I just use my right arrow, and I scroll along until I get pretty close to my second intersection. Looks like I'm still going. There we go. And that's somewhat close. I'm okay with that. So I hit enter. That jumps it automatically from my blue line to my red line, to my second equation, and it says second curve, and it's automatically the closest spot, and I say that's great. So I hit enter. And it asks me to guess, and so I hit enter, and it will take a second, and it will tell me that my intersection on that one is x equals 1, y equals 5. Okay, so now we're going back over here. I've got x equals 1, y equals 5. Well, we knew that on this one, both of my y values were going to be 5. That's my red line here. That's my horizontal line. All of my y values on that one will be 5. So it really tells us what our x values are. My x value is -5 and +1. So my answer to this one is x equals -5 and +1. Again, I have two answers, x equals -5 and +1.